You're watching Code Like an Architect series with Adil Atta on Archi Wisdom. Object-oriented programming and high-level languages provide many features for designing a single object. These features form a rich toolset or feature set that can be used to design an object according to our specific needs. You don't just pick from these features randomly based on what's new or what's trendy. Instead, you use this feature set thoughtfully based on the specific design needs of each object. To better understand this, consider a Lego example, where each piece is designed individually with a specific purpose, depending on what we ultimately want to create and where it fits in the overall picture. You can't simply make all the pieces as squares or circles just because it's convenient. No, you design each piece thoughtfully, ensuring that it serves its unique role. The same applies to objects. These individual objects collectively form your entire application. You can't make all your objects identical. Instead, you design each and every object thoughtfully and carefully based on its specific role in the overall application. And all these features are available to help you fine-tune the details of each object. The most fundamental concept in designing a single object is the concept of a class. A class acts as a specification or blueprint that we can define once and use repeatedly to create objects of the same type. Essentially, a class serves as a template. A class can have two types of members: attributes and methods. Think of any object and you will be able to identify these two types of members easily. For example, consider a car. It has attributes like color, model, number of seats, speed, and it has functions or methods like drive, reverse, park, change gear. Similarly, think of a file. It has attributes such as name, size, type, and it has methods like open, close, copy, rename, delete, and so on. Let's talk about attributes. For every attribute, we can decide on every detail. What type is it going to be? A built-in type or a user-defined type? Can it hold all possible values of the type or only a specific set of values? Will it be value-based or reference-based? Mutable or immutable? Nullable or non-nullable? Will it be instance level or shared? See how many choices we have available just for designing a single attribute. It's crucial to understand that these are not just some random choices. You don't just pick up something because you like it, or because it's trendy, or because it's your default way of doing it. No. You fine-tune each detail to fit your specific scenario. If you need to store an integer and the valid values can be 1, 2, or 3, you can either use an integer with added validation or opt for an enum, which cannot even hold any other value in the first place. That's a small decision that you have to make. Suppose we need a variable to store the value of pi. Should we make it constant or read-only? What's the difference between constant and read-only? Before finalizing a choice, we must know the difference and the consequences of choosing one over the other. The more we know the features of a language and the deeper we understand them, the more versatile and enriched our feature set will become. Consequently, the more control and power we will have to fine-tune our design. Now let's talk about methods. You can create your own custom methods. You can carefully craft each detail, its name, return type, parameters. You can mark it static, async, virtual, override, sealed, new. You can use method overloading to provide multiple and flexible ways to call a method and allow various types of input and scenarios. Question: why do we have so many options just to create a single method? These options empower you to design even the smallest details of your object with great care. By carefully crafting your object, you can improve your overall coding experience and prevent many bugs and inconveniences. Let's look at some examples to understand this better. This method is expected to return a number. However, since its return type is a string, it could return something that isn't a number, leading to a bug at runtime. By simply changing the return type to int, we can ensure the method only returns integers. If the method tries to return anything other than an integer, the code won't compile. This provides early feedback and helps prevent potential bugs. By making a small decision of using int instead of a string, you gain both reliability and clarity. We are solving our programming problems by designing objects. By carefully designing an object, we can prevent many problems by addressing them once rather than every time. See another example. This method creates a user using first name and last name. While this is still a valid scenario for creating a user, there are cases where we might also want to receive additional data if available. If you modify this method directly, it could break the existing references in the code. However, if you are familiar with method overloading and understand how it helps preserve backward compatibility, you can avoid potential inconvenience. By choosing the appropriate feature in a given scenario, we enhance our coding experience. See one more example. Suppose you want to find a student based on their name, the ID, and the date of birth. You can create these three methods. But you can also create a single method accepting a delegate, and then you can call it like this. Which one is better? This one or this one? The answer is, it depends. If you want to make it generic and apply it to scenarios beyond these three, then this option might be a good fit. On the other hand, if your search expression is complex and needs to be reused in multiple places, and you want to encapsulate it, then this approach could be more suitable. Additionally, if you want this to work for other types as well and don't require any type-specific handling, you can make it generic. All of these features are available at your disposal, allowing you to design the internals of your object to fit your specific use case. One of the key responsibilities of a software architect is decision making. By developing architect's mindset, you bring the advantages of thoughtful and well-informed decision-making even to the finer details of coding. In addition to custom methods, you have some specialized methods as well. For example, constructors. Using constructors, you can design the creation process of your object. Do you want to compose the object using multiple subcomponents? Do you want to initialize its attributes at the time of creation? Do you need to configure some dependencies? Do you want to control who can or cannot create an instance? Would you prefer to allow multiple and flexible ways of creating the object? Or keep it limited and controlled? Or perhaps you don't want it to be created at all. You only want to allow the creation of its child classes. Look at all the choices we have available just at the time of creation. While you might already be familiar with these options, the key takeaway is the mindset. We are designing the creation of an object. Think of constructor not simply as a way to create an object, but a powerful design tool that shapes how your objects come into existence. When you write a constructor, you're not simply initializing some values. You are crafting the process of creation. All these capabilities give you the power to approach this thoughtfully and ensure that object is constructed exactly as needed. Just like constructors, we have destructors that are used to clean up internal resources at the time of disposal. Then we have deconstructors in C# and some other languages, which can be used to decompose an object into its multiple subcomponents. Another type of specialized methods is operator overloads. Using operator overloading, you can support basic operators in your class. questions that every developer should ask themselves are, do I know what operator overloading is? Do I know more than just the name? Do I realize how many operators I can overload? Is my understanding of operators just for passing an interview, or do I apply it practically? Have I ever overloaded an operator in my projects? Do I even consider operator overloading when designing a class? Ultimately, it's the mindset that makes the difference. It's the approach that sets you apart. We also have conversion operators, which we can use to support conversion between different custom types. We have indexers, which enable array-like interaction with a class. We can create extension methods. We can create a generic method in C# to reuse the same implementation with different types without compromising type safety. We are not going to cover all these features in detail here. My emphasis is on developing the right mindset. I aim to offer a clear and insightful perspective. We are designing an object, and these features are there to help us. Other important concerns while designing an object include access modifiers and class modifiers. In the end, the key takeaway is the mindset and the approach. It's not always about learning new and complicated concepts. Many times, it's about viewing the same things but from a different perspective.